Are you looking for a school that nurtures your child's academic, spiritual, and personal growth? Andalusia Academy International School, where your child's future is our priority. We offer comprehensive education levels: kindergarten, Pearson I Primary Certificate, secondary, and Pearson IGCSE certificates.
We are a school that emphasizes in the Deen and Dunya. It's integrated in that on the side of Islamic studies, we have Quran, we have Hadith, we have Arabic. And then, of course, in the secular side, we have all the subjects.
We focus on student-centered learning, where we engage our students in different levels. Other than that, we have very innovative teachers who help to cultivate creative thinking, problem solving, which are very, very key skills in learners, not only in school, but also for their future.
Hello everyone, my name is Aisha Mohammed and I'm a student under Andalusia International School. I've been here for the past 5 years and I'm in year 11 right now, and my experience in this school so far has been amazing.
Admissions are available. Visit us today. We are located in Nairobi, South Sea. Andalusia Academy International School, where your child's future is our priority.
Welcome to our today's episode. My name is Teacher Kasim. I'm a teacher of Math and Chemistry, and I teach at Andalusia Academy. Last time, we had a discussion on the chapter of Inorganic Chemistry, whereby we discussed about things to do with the introduction part. We did the hydrocarbons, we did the crude oil, we did the alkanes, and now we shall narrow down our discussion to the alkenes. And last time we also discussed about the alkenes. We discussed about their nomenclature, we discussed about their isomers, we discussed things to do with the chemical properties, especially on when the alkenes burns in air. So when alkenes burns in air, we said that we form two products, water and carbon dioxide, if that is excess supply of oxygen. But if it's limited supply of oxygen, we say that we form water and carbon monoxide. We finished on the combustion part. Now we need to narrow down our discussion and talk about the addition reactions in alkenes. And when I talk about addition reactions, there are different types of addition reactions in alkenes. We have the hydrogenation and we have the hydration. We have also the halogenation. So I'll narrow down to the halogenation first. I'll start with the halogenation. So you realize that in every alkene, the carbon-carbon double bond is a functional group in the alkenes. And when alkenes undergo addition reactions, the double bond is knocked out and we end up forming a carbon-carbon single covalent bonds. So halogenation is actually the addition of halogens in the alkenes, and the addition happens at the double bond. So I'll give an example of this reaction and how it happens and what are the products. So I have, if you have an alkene like an ethene, so addition reactions occurs at the carbon-carbon double bond in alkenes. Occurs at carbon-carbon double bond in alkenes. So I'll give the first example. When you react ethene, for example, and you had chlorine. This is an alkene called ethene. This is halogen. So when the two react, there is no condition for this reaction. When the two react, the double bond is replaced by a single covalent bond. So we form carbon, carbon, hydrogen, 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 and hydrogen. So this is ethene, and we form a 1,2 dichloro ethane, a 1,2-dichloroethane. This is a good example of addition reaction in alkenes. Second example, we can have a propene or prop-1-ene. This is a prop-1-ene. So when we add a bromine, for example, we form carbon, 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 Br, hydrogen. This is 1,2-dibromopropane. 1,2-dibromo, sorry. 1,2-dibromopropane. These are two examples of the addition reactions in alkenes and on the part of the halogenation. Halo means the salts. We are adding halogens. Second example is hydrogenation. When we react the alkenes with hydrogen, we just form the respective alkanes. For example, if you react the ethene plus hydrogen, when you add hydrogen, you form ethane. If you react the propene with hydrogen, you form propane. If you react the butene and hydrogen, you form butane. So I'll give the first example on the hydrogenation. So number 2, hydrogenation. This is a reaction. This is the reaction between alkenes and hydrogen gas. There are some conditions for this reaction to take place. There's a catalyst called a nickel catalyst, and you must use temperature of around 200 to 400 degrees Celsius. So the conditions for the reactions. Nickel catalyst. We have nickel catalyst, and we have temperature of about 200 degrees Celsius to 400 degrees Celsius. So we have just said when you react the alkenes with hydrogen, you form the respective alkanes. The first example, this is ethene, and you had hydrogen. This is a gas. So the double bond splits to give you a single covalent bond. So we shall have a carbon, carbon, hydrogen, 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 and hydrogen. So here we have nickel catalyst, and we have 200 degrees Celsius to 400 degrees Celsius. This is ethene. This is ethene, then this is ethane. This is ethene, this is ethane. So these are alkenes reacting with hydrogen gas to form the respective alkanes. That is a part on the addition reactions of the alkenes. Now we need to narrow down our discussion also and talk about the test for unsaturation, the test for the presence of double bonds in alkenes. How do we determine the presence of a double bond in a given alkene? We must do a series of tests to determine or to establish that a given alkene has a double bond. And in this case, we normally use bromine water. So if you want to test for the unsaturation, you use the bromine water. Bromine water is orange. But the moment you react bromine water with any given alkene, it will change the color from orange to colorless. And most of the occasions, we call that reaction as a test for the unsaturation, or the test for the presence of double bonds in alkenes. Our next part is on the tests for unsaturation. Test for our next part is on the test for unsaturation. So we can say that the carbon-carbon double bond is the functional group in the alkenes, and we want to determine how we can test for the presence of carbon-carbon double bond. So we shall say that the carbon-carbon double bond is a functional group in alkenes. The functional group determines the chemical properties of a given compound. So we have said that the moment you add bromine water in an alkene, the carbon-carbon double bond breaks to form a single covalent bond. So on addition of bromine water, the carbon-carbon double bond breaks to form single covalent bonds. So I'll give an example of this reaction. So we can take an example, can have an example. So I'll pick an example of the propene or propene reacting with bromine. So if you have a propene, so this is hydrogen. This is sometimes can be called a prop-1-in. Prop-1-in because we must specify the carbon atom that bears the double bond. The carbon atom in the first contact with the double bond. So it's carbon number 1. That's why we call it prop-1-in. So the carbon atom is in the first carbon atom actually is in contact with the double bond. So that's why we call it prop-1-in. So when I had bromine, Br2, these reactions, there are no conditions for these reactions. There are no conditions. So we only have these bonds splitting to form single covalent bonds, and these two bromines will add into each of the carbon atoms. So we have carbon, carbon, carbon. This is hydrogen, hydrogen, bromine, bromine, hydrogen, 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 and hydrogen. This compound is named carbon number 1, carbon number 2, carbon number 3. So at carbon number 1, we have a branch group. It's called a bromo. Carbon number 2, we also have a bromo. So the name of this one becomes 1,2-dibromo propane. 1,2-dibromo propane. Notice that we don't have any double bonds anywhere. So it's a good example of an alkane. But now a 1,2-dibromo propane. So what happens now? How do you determine that? How do you test for the unsaturation then? So we need to say that the bromine water, which color? Color orange, is decolorized. It changes the color from orange to colorless. The color changes from orange to colorless. And this is what we are calling test for unsaturation. The test for unsaturation. the test for the presence of the double bond. So this is how we test for the unsaturation. A small bit that was just left on the other reactions of alkenes. So other reactions of alkenes. Alkenes also undergo other reactions to form different products. For example, there's a reaction that is undergone by only the alkenes called hydration reaction. So we have the hydration reaction. And in this reaction, the alkenes reacts with water to form alcohols. And this reaction has some conditions. So the conditions are the temperature of around 300 degrees Celsius. We have a phosphoric acid catalyst. We have a pressure of around 60 to 70 atms. And also we have the starting material, which is basically the water and the ethene. So we shall say that the alkenes reacts. The alkenes reacts with steam to form alcohols. Steam to form alcohols. There are conditions for the reactions. Conditions for the reactions. Conditions for the reaction. So we have one, the steam and alkene as the starting materials. Two, we have pressure of 60 to 70 atm. Then we have the temperature of 300 degrees Celsius, and we have a phosphoric acid catalyst. Phosphoric acid, and we have the phosphoric acid catalyst. So these are the conditions for the hydration reaction in alkenes. So I'll give the equation for this reaction. So a good example is the ethene. This is ethene, and you react with water in gaseous state. Of course, you have your conditions. Here is the H3PO4, that is the acid catalyst. We have the 60 to 70 atm, which is the pressure, and 300 degrees Celsius. So we form the respective alcohol. So we form ethanol. So this is ethene, and we form ethanol. Carbon, carbon, OH. Hydrogen, 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 and hydrogen. So this is ethene, this is ethanol. Ethene and ethanol. Good. Now those are the different reactions that we have in alkenes, the addition reactions of alkenes. Now we don't need to narrow down our discussion and talk about a different subtopic that is on there. Actually, we have done the alkenes, we have done the alkanes, we have done the crude oil. Now we need to narrow down our discussion and talk about the alcohols. The alcohols is our next subtopic. So alcohols. Alcohols. So in our previous discussion, we observed that the functional group of the alkanes is a single covalent bond. The functional group in alkenes is a double covalent bond. Now, the functional group in alcohols is the presence of a OH group. The functional group in alcohols is the presence of an OH group. So we shall say the functional group in alcohols, is the OH that is attached that is attached to the carbon chain, attached to the carbon chain, that is attached to the carbon chain. So all the alcohols must possess the OH group. All the alcohols must possess the OH group. I want to give different examples of alcohols, their displayed formula, their structural formula, their molecular formula, and their name. So in just one column. That is on the nomenclature of the alcohols, the naming of the alcohols. So our next part is on naming of alcohols. Naming of alcohols. And we have the name. The first column is column of the name. We have the molecular formula. We have the structural formula. And we have the displayed formula. So the first member in the homologous series alcohols is called a methanol. Methanol is the first member. Notice that the meth counts the number of carbon atoms that are in that alcohol. Then ol is a functional group in alcohols. The an part represents the what? Represents the saturated alkanes. So an will represent the saturated alkanes. So methanol, the molecular formula of the methanol, notice that every carbon atom, if you understand how to write the displayed formula, you can easily understand how to write down the structural formula and the molecular formula. So I want to begin by drawing the displayed formula of methanol. So this is one carbon atom. So we have one carbon atom, and we must attach a OH group simply because it's an alcohol. So you find that this is H, H, and H. Every carbon atom must have 4 covalent bonds. So this is the displayed formula of the methanol. So from here, I can easily be able to write down the structural formula. So this is the structural formula of methanol. 3 hydrogens and 1 carbon. So a CH3, then I attach the OH. That is the structural formula of the methanol. So from here, I can also be able to easily write down the molecular formula of the methanol. So how many carbons are here? Only 1 carbon. Then we have how many hydrogens? 1, 2, 3, 4. 4 hydrogens. And of course, we have 1 oxygen atom. So that's the first member of the alcohols. Second member is ethanol. Or ethanol. And we discussed about this in the alkanes part when we talked about the alkenes. The Eth stands for 2 carbon atoms. So I'll proceed to write the displayed formula of the ethanol. Then from the displayed formula, I can easily write down the structural formula and the molecular formula. So 2 carbons, and then I must attach a OH group. So here we'll have hydrogen, 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 and hydrogen. So that is the displayed formula of ethanol. Then from this displayed formula, I said I can easily write down the structural formula. So we have 3 carbons in the first, so we have 3 hydrogens in the first carbon. So the CH3, this is this part. Then this second carbon has 2 hydrogens, so CH2. And the last part is a functional group OH. So that is the structural formula of ethanol. Then from the structural formula, I can easily write down the molecular formula. So we have 2 carbons here in this compound. So C2. We have 6 hydrogens. 6. Then of course we have 1 oxygen atom. So that is how we are able to show the displayed formula, molecular formula, structural formula, and the name of a given alcohol. And the list is long. We can also have the propanol, we have the butanol, we can have the pentanol, we can have the hexanol, we can have the heptanol, we can have the octanol, we can also have the nonanol, and can have the decanol, and so on. So this is just part of the alcohols that we have discussed. Now the next part is on the oxidation of alcohols. Oxidation of alcohols. So I'll go to the oxidation of alcohols. You have the oxidation of alcohols. So I will say briefly, alcohols burns in air to form water and carbon dioxide. Water and carbon dioxide. So I'll give you the equation for this. So we have, for example, the ethanol, CH3, CH2, OH. If you burn it in air, we form water and carbon dioxide. This is basically on the combustion. It's basically on the combustion reaction of alcohols. Now, on the oxidation part, we basically talk about what happens when alcohols are exposed in either oxygen or they are exposed in the oxidizing agents. We have two different types of oxidizing agents. We have the potassium dichromate 6 and we have the potassium manganate 7. When the alcohols are oxidized by the potassium dichromate 6, they form carboxylic acids. For example, ethanol forms ethanoic acid. Propanol forms propanoic acid. And again, there is a proof of oxidation. How do we tell that oxidation reaction has taken place? We observe the color change because the potassium dichromate 6 is orange in color. But after oxidation, we end up forming a green color. Why? Because the chromium 6 ions in the potassium dichromate 6 are reduced to chromate 3 ions, which are green in color. That is after the oxidation. So the moment you observe a color change, then you can tell that there is oxidation. Again, we can use the potassium manganate 7. When potassium manganate 7 has oxidized or oxidizes an alcohol to form a carboxylic acid, it will change the color from the purple color to colorless. Why? Because the manganate 7 ions that are responsible for the purple color are reduced to manganate 2 ions, which are colorless. So that is a test for the oxidation reactions in alcohols. That's how you can be able to tell if there was an oxidation reaction. Because when these alcohols are oxidized, they form carboxylic acid. And how do you test that you have formed a carboxylic acid? There's what you call the test for the what? Test for the acidity. Because a carboxylic acid must have hydrogen ions. So you can test for the acidity. You can either add a sodium carbonate and see if you observe a fizzing what? A fizzing sound, or there will be effervescent sound. So that's the test for the acidity. So once the alcohols are oxidized, we form a carboxylic acid. So I believe that in our next episode, we shall have the notes on the oxidation of alcohols to form carboxylic acid. We shall have the notes on the oxidation of the oxidation of alcohols form carboxylic acid, and we shall also note down the color changes when these compounds have oxidize the alcohols to form carboxylic acid. Thank you so much for your time. Teacher Kasim here. See you in the next episode. Thank you.
Are you looking for a school that nurtures your child's academic, spiritual, and personal growth? Andalusia Academy International School, where your child's future is our priority. We offer comprehensive education levels, kindergarten, Pearson I Primary Certificate, secondary and Pearson IGCSE Certificate.
We are a school that emphasizes in the deen and dunya. It's integrated in that on the side of Islamic studies, we have Quran, we have Hadith, we have Arabic. And then, of course, in the secular side, we have all the subjects.
We focus on student-centered learning, where we engage our students in different levels. Other than that, we have very innovative teachers who help to cultivate creative thinking, problem solving, which are very, very key skills in learners, not only in school, but also for their future.
Hello everyone, my name is Aisha Muhammad and I'm a student under Andalusia International School. I've been here for the past 5 years and I'm in year 11 right now, and my experience in this school so far has been amazing.
Admissions are available. Visit us today. We are located in Nairobi, South Sea, Andalusia Academy International School, where your child's future is our priority.